Hello everybody and welcome to section 7.5. It talks about angles of elevation and depression. Angle of elevation is the angle between the line of sight and the horizontal when an observer looks upward. So here's kind of an example of what we're talking about here. Say someone's standing at their house looking up at a range of mountains. The angle of elevation is the angle that their line of sight makes with against the horizontal or ground where they stand. As you can see, there's the angle of elevation right there. Line of sight right there. Here's an example of a type of problem that we'll be working with in this lesson. The peak of Goose Bay Mountain is 400 meters higher than the end of a local airstrip. The peak rises above to a point of 2,025 meters above the end of the airstrip. The plane takes off from the end of the runway in the direction of the mountain at an angle that is kept constant until the peak has been cleared. If the pilot wants to clear the mountain by 50 meters, what angle of elevation should be for the takeoff to be to the nearest tenth of a degree? So the idea here is there's the mountains, there's the plane taking off, and what we want to avoid is him crashing through the mountains. We want to make sure we clear the mountains. So we have to stay 50 meters above the top of the mountain, and we can do that by determining the angle of elevation. So here we have a right triangle. The line of sight, or the path of the airplane, is going to be the hypotenuse of the right triangle. The height of the mountain is the opposite side, and the distance from the airplane to the mountains is the adjacent side. So we'll be working with this type of right triangle to set up our problem. Okay, but that's just an example. We'll talk about how to do these problems later on. Angle of depression is the angle between the line of sight when an observer looks downward in the horizontal. So back to our original illustration. Let's say an observer is on top of the mountain and he's looking down at the house. Then that is formed our angle of depression right here. The angle from the horizontal on top looking down to the line of sight. Notice we have line of sight here, and then we have alternate interior angles because we have two parallel lines of the horizontal where an observer would look and the level ground. We do have alternate interior angles. So the angle of depression would equal the angle of elevation if the perspectives were switched. Here's another description of the type of problem we'll be dealing with in this unit. Olivia is in a lighthouse on a cliff. She observes two sailboats due east of the lighthouse. The angles of depression of the two boats are 33 and 57 degrees. Find the distance between the two sailboats to the nearest foot. Let's just talk about this situation. Say the cliff is 110 feet. Say the lighthouse adds another 85 for a total of 195 feet. And here comes the two boats. And it is determined that at the top of the lighthouse, the angles from each boat are the 57 and 33 degrees respectively. So what we would have to do is find the angle of depression for both of those, which they are given, and then use trigonometry to find how far each boat is from the lighthouse, and then at the end we would just subtract those two distances to find out how far the boats are from each other as the question asks. And there's our right triangle, as we can see. Okay, thank you very much.